Okay, so we're going to look at how to solve some equations that involve exponential expressions. So, first problem. Solve 8 to the 2 minus 2a equals 32 to the a. So to do this, we got to know a couple of properties. So first off, if I have an equation where I have two exponential expressions, but one, they have the same bases but different exponent values. If that's true, right, so we write if, then what has to be true in this case is that the exponents equal each other. So if you look here, 8 and 32, those are obviously not the same base. But the neat thing is that 8 and 32 are both powers of a different base, in this case 2. So I can rewrite 8 as, right over here, 2 to the power of 3, with the 2 minus 2a here. And 32 is 2 to the 5th. So you can see how I took 8 and 32 and just rewrote them in terms of powers of 2. Now, does this look like something to a power and something to power? No, so we got to keep working. So we have another property, it's called a power of a power to a power property. It says this: if I have a power and I raise that to another power, I combine the exponents by multiplication. So here, the power inside on the left is 3. The power on the outside is the expression 2 minus 2a. So n times n would be 3 times this expression. So I'm going to distribute the 3 through that. So I get 2 to the 3 times 2 is 6. 3 times negative 2a is 6a. And that's going to equal 2 to the 5th to the a. So 5 times a is 5a. So now what I have, something to a power equals something to a power. Same somethings, different power. So I can actually now use this. And I can solve a by saying, well, if they have the same bases, and they're raised to a power and they're equal, then they have to be the same power. So my solution is going to be the value of a that makes these powers equal. So I'm going to set up and solve. So to solve this, I'm going to move the 6a over by addition. So I get 6 equals 11a. And divide both sides by 11. So a is going to equal 6 11s. Let's do one more. Okay. So now I'm going to solve 64 to the negative 3x equals 16 to the 2x plus 2. So again, I want these to be the same base. They are not, but they're both powers of a different base. In fact, they're both powers of 2, but they're also powers of 4. So I can use 2 here, but I'm going to actually use 4. So 64 is 4 cubed. So let me write this as 4 cubed to the negative 3x. 16 is 4 squared, so this is 4 squared to the 2x plus 2. Now I'm going to use the power of a power property to make this each of these expressions have one exponent. So 3 times negative 3x gives me negative 9x as the power on the left. 2 times 2x plus 2 gives me 4 to the 4x plus 4. Same powers, different exponents equal to each other. Well, the only way that's true is if the powers or exponents equal, so I'm going to set them equal to one another. To solve this, I'm going to subtract that over, so I get negative 13x. And so x has to be negative 4 over 13.